writing linear equations in point-slope form. As the name indicates, if we have a point on the line and the slope of the line, there's a very quick and easy way to write the equation of that line using the point-slope form. Point-slope form looks like this. Y subtract y sub 1 equals m times, in parentheses, x minus x sub 1. The m in this equation represents slope of the line, and the x1 or the x sub 1, y sub 1 represents a coordinate on the line, and it could be any particular coordinate that is on the line. It doesn't matter which one. As long as you know one coordinate, you can use this formula, or this form rather, to get the equation of the line in point-slope form. Now recall that the x and the y are just variables that represent all the other possible points on the line. So every single point on the line is represented by the x and the y, and that's why they remain variables, because they represent multiple different points on the line. All right, so let's just take a quick look at a couple of examples. Here we have an example. Let's write the equation of the line in point-slope form that passes through the point 2, 3 with the slope of 2. Very simply, we use our form y minus y sub 1 equals m times x minus x sub 1. And recall that m is our slope, so we'll just substitute in our numerical value 2 for slope. And x sub 1, y sub 1 are the coordinates of a point on the line. The only point on this line that we know is the 2, 3. The x coordinate here is 2, so we have x minus 2. And y minus the y coordinate 3. And very quickly, we have the equation of the line that passes through the point 2, 3 that has a slope of 2. Very simple. All right, let's step it up a notch and get a little more complex example. Let's write the equation of the line in point-slope form that passes through the points -1, 2, and 3, 7. Well, in order to write the equation in point-slope form, I know that I need a point on the line, which I'm in great shape here because I know 2 different points on the line, and I need the slope. Well, that's a little bit more challenging because now we have to find the slope before we can put the equation in point-slope form. Well, we know how to find slope using the slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And plugging in our values here, we have 7 minus 2 over 3 minus -1, 5 over 4. Our slope is 5/4. Now that we have our slope, we can use our point-slope form. Y minus y sub 1 equals m times the difference of x and x sub 1. And simply plugging in values for x1, y1, and m, y minus. And now we get into a little conundrum. We know 2 different points. And remember, I said that any point on the line works, so you could really use either one of these 2 points. We could have the equation y minus 2 equals 5/4 times x minus -1 or x plus 1. Or we could use this point and get the equation y minus 7 equals, again, the slope 5/4, the slope doesn't change, times x minus 3. These are both correct answers. This is one of the shortcomings of point-slope form, is that there are several different ways to express the same equation in point-slope form, and they all look different. But just to demonstrate that these 2 are both the same equation, I'm going to solve them and put them both into slope-intercept form. And we'll just see that they come out to be the exact same equation. So if I solve both of these equations for y, I'm going to simplify 5/4 times x plus 1 as 5/4 x plus 5/4. And y minus 2 equals this, adding 2 to both sides, which 2 is the same as 8/4. So y equals 5/4 x plus 5 plus 8 is 13/4. So we have y equals 5/4 x plus 13/4. Similarly on this side, 5/4 x, and here we're going to have minus 15/4, and y minus 7 will equal this one, adding 7 to both sides. Now 7 would be 28/4. 28 plus negative 15 would be 13/4. So y equals 5/4 x plus 13/4. Notice that both of these equations gave me the exact same equivalent slope-intercept form.